Good morning, students. So, in this lecture, we shall come to know how to develop a lateral surface of a cylinder or how to develop a surface of a cylinder. So, this is a given problem in which the base diameter of a cylinder is 50 mm and the height is also 50 mm, and this cylinder is resting on its base. Now you have to develop a lateral surface of a cylinder in a given problem where two dimensions are given, that is a diameter of a cylinder and a base of a cylinder, right? Now this one is the solution to this problem, so we shall discuss one by one how to draw these views. So here you can see this one is a top view, this one is a front view, and the last one is the developed lateral surface of a cylinder, right? So there are certain steps to draw this one. So initially, we have to start from the front and top view of a cylinder. So, if you observe a cylinder from its top, then you will observe that it is in the shape of circle, right? So, here I have drawn the front view and top view of a cylinder in first angle projection, right? What is first angle projection? The projection in which front view is drawn above the reference line and top view is drawn below the reference line. So what will be the first step? In the beginning you have to draw this reference line xy, right, to a suitable length that is obviously more than the diameter of a cylinder, right? Now you have to start from the top view of a cylinder, and how it look like. So it look like a circle from the top. So first of all you have to draw a center lines for this cylinder, this one and this one, right? Then you have to draw this circle by taking a radius of 25 mm, so that you will get a circle of 50 mm diameter, right? So what is the first step? You have to draw a circle with 25 mm radius, right? Then in the second step you have to divide this circle into 12 parts. So if we divide this circle into 12 parts, then one part will be equal to 30 degrees. Similarly, if you divide this circle into 8 parts, then one part will be equal to 45 degree. Now what is the rule? Why we are dividing this circle into so many parts? So as per rules, you have to divide this circle in such a parts so that the number of parts will be the multiple of 2. But for the time being you can divide this circle into 8 or 12 parts, right? So if we divide uh, the circle into more parts, then the complicacy of the drawing is being removed, right? So for the ease of making this drawing, you have always to divide this circle into 8 or 12 parts, right? Now here one part is equal to 30 degree, right? Now after dividing this circle into parts, you have to give numbering to these parts, right? Now if you carefully observe the cylinder from the top, then you will only get a top of a cylinder, right? So how it is possible? It is only possible if we consider this cylinder as a solid object, right? Now only the top view of the, or the top portion of the cylinder is visible from the top. However, there is a base of a cylinder which is behind the top, right? So we all in the drawings we also have to show the features which are not even visible from any directions, as we did in the orthographic projections, right? What we do, we also represented the hidden features, right? So here also we have to represent the top, but all we also have to represent the base of the cylinder. And how it is done? It is just by giving the numbering to the top view. So here we have given this numbering 1, 2, 3, 4, 5, 6 up to 12 in the form of numerics to the top of a to the top portion of a cylinder, whereas for the base of a cylinder we have given the numbering in the form of lowercase alphabets, that is A, B, C, D up to L, right? It means these numerics are representing the parts of a top, and the lowercase alphabets are representing the base of a cylinder, right? So in this way you will complete the top view of cylinder. Only you have to give this dimension, which is the diameter of cylinder, which is equal to 50 mm, right? Now one more thing here you have to remember: the lines which we have drawn here, these lines, these are construction lines, right? These lines are uh, construction lines, or you can say these are continuous thin lines. These are uh, continuous thin lines, or and the name of these lines are projectors. These are also known as projectors. The technical term is projectors, but you have to use a continuous thin line to draw these lines, so that only the object, which is this circle, should come out of your sheet, or should be highlighted out of your sheet, because we only have to use the object line for drawing this circle, right? Now in this way you will get a top view of a cylinder. Now we have to draw the front view of this cylinder, and how it is done: you have to take the projections from the top view, right? So this one is the extreme end, and this one is the extreme. So from there we have to draw the projection line. Similarly for this part, this one, and this one. So you have to take the projections for the front view, right? From for the front view from the top view. And what is the given height of a cylinder? The given height of a cylinder is 50 mm. Now you have to extend these lines, these all lines, with 50 mm height, so that you will get a front view of a cylinder. So if you observe a cylinder from its front, you will get a shape of rectangle, right? So I already discussed this concept in the classroom. So this one is the front view of a cylinder. Now in the beginning what we did, we gave numbering to the top and base of the cylinder. So here in the front view you can clearly see we have given the numbering in the form of numerics on the upper side, this one, and in the form of alphabets on the lower side. Now here you can clear the concept why we give the numbering of uh, top as well as base, right? Now here I have written a dash, B dash, C dash, D dash, E dash, F and G on the lower side, and some points like H, I, J, these points on the upper side. Why I have written like this? Because if you observe a cylinder from a front, only the portion up to these 2 points is visible. Let us suppose this is point 1, this is point 2. These are the center point of the cylinder, only this portion is visible from the front. This back side is not visible from the front. Only this front side is visible from the front. So in the front side we have point 1, then 2, then 3, 4, up to 7. So this is point 1, this is point 7. So points from 1 to 7 are visible, right? Only point 1 to 7 are visible from the front. Here you can see point 1, 2, 3, 4, 5, 6, 7. Rest of the points are on the back side, on this side. Rest of the points are on this side. So these are not visible from the front. That is why we have written these points on the lower side. Right, students? Now, similarly, for the base, some points are visible from the front, but the points which are on the back side, that are not visible. That is why we gave numbering like this one. We gave numbering to the points which are visible from the front on the upper side. For the points which are not visible, we have given the numbering from the from on the lower end, on the lower side. Now in this way we'll get the front and top view of a cylinder. Right now we have to develop a lateral surface of a cylinder. Now what is the developed lateral surface? We already discussed in the class how we get the developed surface of any object. We have to cut the object, right? First step is cutting of an object, second step is unfolding of an object. We have to cut the object, then unfold it. Once we unfold the object, then we'll get the lateral surface or developed surface of a developed surface of an object. We already discussed in the classroom in the beginning lectures, and we already discussed this one in the introductory lecture of development of surface. Now what we have to do, once we cut this cylinder along the axis from anywhere, then we'll get a flat sheet, right? So I already discussed in the introductory lecture, we'll get a flat sheet, this one, like this one. Now the height will remain same, 50, right? Now what will be the length of this sheet? The length of this sheet will be 2 pi r, equal to the circumference of a cylinder. So the length is equal to, this length is equal to 2 pi r, where r is the radius of cylinder, that is 25 mm. So if you calculate the circumference here, you will get this length is equal to 157 mm, right? So it means you have to take this height of 50 and this length of 157, then you have to complete this rectangle. So after this you have to uh, divide this rectangle into the same number of parts as we did in the top view. It means 12 parts, these parts. So this is first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11 and 12. So it means you have to divide 157 by 12. So one more thing to notice in this developed surface is that the starting point, if the starting point is 1, then your last point should always be a 1. So that if we have to again construct this cylinder or join this sheet to form a cylinder, then we have to connect this end, the first end, with the last end. So the first and last point should be the same. Then only your drawing is correct. Otherwise, it is incorrect. If you have divided your if you have divided your object in certain parts that your first and last point is not matching, then it is incorrect, right? Now this is the simplest way. You can simply divide this length by number of parts. Then the second method is you can also use acute angle method, which we the method which we use in case of diagonal scale. So here we can take any acute angle, right? So we have to mark points with at a identical distance, that is at a same distance, so that we'll get a equal number of parts. So this is optional. Either you can simply divide this lateral surface into equal number of parts, or you can use acute angle method. So finally you have to give the dimension to this lateral surface. So this is all about the development of a surface of a cylinder. So I have already mentioned all steps in this slide. You can follow these steps starting from the drawing of a reference line. You can easily draw this. So these are some of the references. This one is the textbook, then NJ Jolly, and this is a link. There is a lecture series on YouTube. Also, you can also get in touch with this link to know more details about the construction or development of a cylinder, right? So thank you, students.